Hey, everyone. Good afternoon. Happy Wednesday. All you should need is a paper for today, pen or a pencil, and a calculator. All right, so today we're going to be factoring just like we were, and we're going to be using that information to solve the polynomials. Some polynomials, because of just their nature, they're a little more complex to solve. Some of the ones that are a little complex I'll help give you. But I'll actually be going over tomorrow how to solve some of the complex ones. There's a little formula that goes with it, and we're going to be using more synthetic substitution and kind of be putting what we went over yesterday and what you'll see today together. Only 7 days left, so make sure you're catching up on all your work and just be prepared for the upcoming week. All right, so here's our bell work. You can pause for a second if you want to try it. But essentially for the first one, we're taking out our greatest common factor. And then we can factor this equation. So we're going to use our x method. And we get 5 and -3. And now we set that up. And this is us factoring this completely. Then same for the next one, we're going to take out our greatest common factor. Then we are going to factor this. Now we haven't really factored numbers to the 4th power before, but it works just like the 2nd power. So -8 up top, -2 on the bottom, and we get -4 and +2. Now you'll notice the only difference when we have x to the 4th is now we have x squared minus 4 and x squared plus 2. This will become important later. Now this can actually be factored one more time because x squared minus 4 is a difference of squares. So that turns into x plus 2 and x minus 2. And there you have it. That's our final answer. So here we're using that same knowledge, but we're going to solve. So we want to move our 9 to the other side. And then we have x squared equals 9. And we're going to square root both sides. So square root, we get not just 3, we get positive and -3. All right, the next one we're going to factor first, greatest common factor. And now we're going to do our little x method, or you might already catch on to the fact that it's going to be 4 and -1. Now when we solve this, you're going to set each piece equal to 0. And here you have that if we have x equals 0 and x plus 4 equals 0, x minus 1 equals 0, we get that x equals 0, x equals -4, and x equals +1. And those are how we solve equations by factoring. And so we're going to keep solving polynomials by factoring. We'll solve polynomials by factoring by setting it equal to 0. So the only time you'll mostly need to note this is if it's not already equal to 0. So let's look at this first equation. First, let's start with our greatest common factor. We have 3x to the 3rd, and then we're left with x squared plus 6x plus 9. Now to solve the rest of this, we're going to use our little x method, and we're going to find two numbers that multiply to be 9 and add to be 6. And you will get, 3 and 3. So this is x plus 3 and x plus 3, or x plus 3 squared. Either one is fine. But we'll set each piece equal to 0. Now, you'll notice to solve the first one, all you have to do is plug in 0. And then to solve the next two, it's going to be -3. So our solutions are 0 and -3. And these are often sometimes called the roots. All right, now let's solve this one. Now remember, it's supposed to be equal to 0, so we need to move our 36 back to the other side. It's on the wrong side. I don't know what it's doing over there, but let's move it on over by adding 36 on both sides. So now that we've added 36, we get x to the 4th minus 13x squared plus 36. Make sure you remember that it's x to the 4th because that'll come into play in just a moment. And obviously feel free to pause at any time if you want to take a second to try to work on it on your own, or if you need a second to catch up on the problem. So we'll use our x method to factor this trinomial, and we want to find two things to multiply be 36 and add to be negative 13. This might not be the one that comes to mind right away because you're like, wait, 6 and 6 is 12. It is actually negative 9 and negative 4, because that is also multiple of 36. So we get x squared minus 9x squared minus 4. It's squared because remember this was an x to the 4th. It works the same way when it was x squared. It's just instead of it just being x minus 9, x minus 4, it's x squared minus 9, x squared minus 4. So you can either now solve each like this, but I just did it out even further. I factored completely. X squared minus 9, x squared minus 4 is a difference of squares. So we get x minus 3, x plus 3, x minus 2, x plus 2, and then we're going to set each thing equal to 0. And we get x equals 3, negative 3, positive 2, and negative 2. And that's our answers. So our roots are plus or minus 2 or plus or minus 3. Here we have 2x to the 6th minus 10x to the 5th minus 12x to the 4th. First, always start with your greatest common factor, which hopefully you've caught on is 2x to the 4th. Now, this leaves us with a nice trinomial that we can solve using our x method. So two numbers that multiply to be negative 6 and add to be negative 5 are negative 6 and positive 1. Now, we just set each of these pieces equal to 0 to solve. And first, you get x equals 0, x equals 6, and x equals negative 1. So a lot of this isn't anything new. It's very similar to stuff we've already been doing. It's just now technically polynomials, and this is like the main stuff, whereas before we were just practicing factoring. So the roots are negative 1, 0, and 6. All right, so here's the piece that's slightly new. It's not as scary as it sounds, but basically the amount of times that piece can be factored or that piece equals 0, we are looking into that. And so right now we're looking at the fact that how many times it multiplies to be that. And later we might talk about whether it's even or odd. The even or odd just kind of affects the way the graph is shaped at that intercept. Because remember, all of our roots are our x-intercepts. So as you can see, when it's even, an even multiple c at that x-intercept, the graph just touches the x-axis, but it doesn't usually cross over. Whereas when it's odd, the graph bends as it crosses the x-axis. So let's take a look to what we mean by something. All right, so here's a problem that we're going to factor. We're going to factor this one by grouping. Some of the others don't work out nicely this way. I'll kind of explain why it doesn't work out nicely, but there's a new formula coming up. Anyway, we can take out an x squared and then a 27, and you'll see this doesn't work out quite the way we are hoping. So here's where our new formula comes into play. And I will give you this formula, and I'm going to go through these type of problems that you have with you, and I'll make sure you're prepared if you're going to have to see anything like this. The formula isn't the main thing you need to know. It's the multiplicity, which I'll explain after we factor. So this is our new formula. And again, I'll give this to you if you happen to need it. We just only had a certain amount, like these are just some of the examples of how to factor some of these. I'm probably going to teach you a new way to factor tomorrow, which will hopefully help you. So you won't even really need to worry about this, hopefully, because if you can factor once or twice, you can then use synthetic division to more easily divide the rest. But this follows this formula, and we find out that this all becomes x minus 3 cubed. And x minus 3 cubed, of course, is the same as x minus 3 times x minus 3 times x minus 3. Now, the whole point of this problem isn't necessarily the factoring, it's the multiplicity. So we want to find out how many times we have certain multiples. So in this case, we have x minus 3 3 times. So the root of 3, because x minus 3 equal to 0, we get x is 3, has a multiplicity of 3 because it occurs in this equation 3 times. And this is going to come into play for what Fridays is, but basically you'll actually notice a certain pattern, so spoilers. The degree of each polynomial should kind of correspond with how many zeros you have. Just some zeros, like this one, it's the same 0 3 times. So here we have another one. I'm just going to give you this one. This one was a really weird one. Basically, you had to manipulate, I think it was the 30x or the negative 12x squared. I had to do it for a bit, but you can do it to the point where it becomes factorable. I'm just going to give this to you because the point is not the factoring in this case, and they expect you to kind of know the other way. It's part of this lesson, but I'm saving it for tomorrow while I'm there to be able to factor. Anyway, I'm giving it to you because the point is the multiplicity. So here you'll see we have a multiplicity of, we have 1 x minus 4, and so our root there is going to be 4. So we have our 1 multiplicity 4, or the root of 4 is a multiplicity 1 time, but x plus 5 shows up twice, so that has a multiplicity of 2, and the root there is negative 5, because again, negative 5 plus 5 equals 0. So feel free to pause if you need a second. Again, I'll show you how to factor stuff like this if you'd like, but the point is just how many times they multiply, and we are only given so many examples that some of them end up being a little funky. So here we're going to factor our greatest common factor, and we get this. And then here's where it gets a little funky again. So I'm going to give it to you. It becomes x plus 1, and then x squared minus 12x plus 6, 36. You should know how to do it from here. So if you want to try for a second, you can. But I'll go ahead and do it with you. This we get -6 and -6, or x minus 6 times x minus 6. So you can see we have a multiplicity right here of x minus 6 twice, x plus 1 once, and x to the third, this is x times x times x, right? So 0 has a multiplicity of 3, -1 has a multiplicity of 1, and 6 has a multiplicity of 2. Or the root of 0 and the root of -1 and the root of 6. So again, this is basically just saying that when x is, or during this formula, if you were to graph it, these are the 3 zeros that the graph would have. Now, it's to the power of 6, meaning it should have 6 intercepts. Well, 0 is counting 3 times, -1 is counting once, and 6 is counting twice. So that adds up to be 6. So that's kind of the fundamental theorem of algebra, something that we'll go over on Friday. But I'm just giving you a heads up now because I think it really ties in well to this. All right, you can practice some in your groups. I can do some with you. Feel free to pause to try it on your own and watch. Some I'm going to have you practice and then I'll give you the answer. And then the last two, the multiplicity ones, I'll do with you in this video. So here we go. All right, so 2x to the fourth plus 16x to the third plus 32x squared. So feel free to pause and try it on your own. But if you're being rebellious or if you're already done, let's go over it. So we can take out 2x to the 2x squared, our greatest common factor. And then we have a trinomial that can easily be factored. We get 4 and 4. And now our last step is to set each piece equal to 0. So for the first problem, x is going to be 0. In the second part, -4. All right. Now in this one, we can already solve using what we normally would do for our trinomial. But keep in mind, it's x to the fourth and x squared. So you'll see what happens there. So we have 36 up top, -37 on the bottom. So we're going to get -1 and -36. And remember, the only difference is that it's x squared minus 36 and x squared minus 1, which means, guys, we have a difference of squares. A difference of squares. So, I guess I should have done that. That's a rectangle. Anyway, this becomes x plus 6, x minus 6, x plus 1, x minus 1. And we're going to set all of that equal to 0. And you get -6, -1, 1, 6. Or you can just leave it as plus and minus 1, plus or minus 6. You could have solved from this step too. And then when you set that equal to 0, you'll square root both sides. And the square root will be plus or minus 6, plus or minus 1. Okay. So here we want to start with our greatest common factor. Oh, sorry. Whoa, we want to move the other thing over. We want to move the 48 over. It's on the wrong side. And then we can do our greatest common factor, which is 4x to the fifth. Now we can solve like we factor like we normally would with a trinomial using our x method. And we get -4, -3. And now we're going to set each piece equal to 0. And we get x could be 0. x could be 4, and x could be 3. Hopefully this is clicking for you. Hopefully this is mostly just review. Oh, I forgot to animate this one. I'll leave this up here for a minute so you can take a second to look through it. I first moved my 4x squared over. I then did the greatest common factor. And I then did my x method, which I believe is right here. Funny how some was edited and some wasn't. But remember, if I'm going to do the x method, the reason this is up here is because I have to multiply my first term to my last term if I have a first term that's different than 1, and then divide by that later, which is the step you see right here. And then 12 divided by 3 became 4, and the other I left as a fraction, and then I set each piece equal to 0, and then we get our final answer right over here. Yeah. All right, so this one we move everything to one side. We're then going to group. First, the first parentheses, we can take out an x squared. In the second parentheses, we're going to take out a negative 16. And now we're going to put these in their new groups. And x squared minus 16 can be simplified, because it's a difference of squares, to x plus 4 and x minus 4. Now, if we set each of these equal to 0, you'll see that our answer is going to be plus or minus 4 and 6. So I don't want to give you all of the answers. Well, I'll give you the answers, but I want you to try this one first, so I'm not going to give you the work. But feel free to pause right now. Try it on your own. You're still here, whoops. And if not, pause now, and I'll give you the answers in a second. Here are the answers. All right, same thing. Pause, and then come back for the answers. So, are you ready? Try it on your own. Try it on your own. Try it on your own. Pause. Ooh, here's the answer. All right, these are I'm going to do with you. That's why I didn't stop the video early, because these are the ones that are a little funky. So this I'll do with you. We're looking for the multiplicity. So we're going to use this equation to create our factor, because it follows this pattern. We get x squared minus 4 to the cube root. Now, the reason that's fun and exciting is because x squared minus 4 is a difference of squares. So this is what x squared minus 4 would look like when you factor that out. And that means we have a whole string of numbers. So x plus 2, or negative 2 is a multiplicity of 3, and 2 has a multiplicity of 3. And again, you'll see that pattern I mentioned earlier. It's to the 6th degree. So in theory, it should have 6 zeros. Now, if you looked at a graph, this would only cross it twice, at negative 2 and at 2. but in reality, it's counting 6 different times, or it's counting 3 different times for those 2 different zeros. Fun. All right, last one until tomorrow. So we have, I'll give you this one again. This one becomes x plus 2 cubed. It is not a difference of squares, so it's just x plus 2 times x plus 2 times x plus 2, which means we have negative 2 is a root 3 times in this equation. And again, our degree is 3, so it just kind of makes sense. All right, I hope you're having an awesome day. Make sure that the room is clean and treat the sub with respect. And I hope you guys had a great day. I'm probably currently enjoying my day, hopefully. And message me on Canvas if you need anything. And I'll see you all tomorrow. Ooh, more factoring. All right, have a great day. Bye.